We are at the end of the Learn New Node workshop. Let's jump right in and tackle those last two exercises. I have my terminal open and I've navigated to the Learn New Node project directory. I've got Chrome open with the Node.js documentation, and I have Visual Studio Code open to my Learn New Node project. I think we are all ready to get started with the next exercise. Let's just take a look at that. HTTP uppercase server. Create a file named http uppercase server.js. Write an HTTP server that receives only post requests and converts incoming post body characters to uppercase and returns it to the client. Your server should listen on the port provided by the first argument to your program. Okay, cool. I think we can do that with what we already know. I don't think I need anything else, any hints or anything like that. It's similar enough to this HTTP file server that we worked on last time. I think we could just duplicate that file and piggyback off of it. I'm going to right click in my sidebar here, my Explorer sidebar, and duplicate. And this one is uppercase server. We don't need fs because we are not doing anything with any files. We don't need a file path. The contents of this response callback will need to change, so I'll just get rid of what's there. Now I'm going to flip over to my documentation because I will need to reference this. I'm interested in the HTTP module, and I'm going to just sort of inch my way through this one step at a time. I'm going to start at create server. The request listener is a function which is automatically added to the request event. Let's go to the request event. It gets a request and a response. The request is the data coming in. So how are we going to get the body out of that request? In order to figure that out, I probably need to look at documentation on this incoming message. I'm just going to pull that up in a new tab. This is a readable stream. It extends the readable stream object. I'm just going to see what properties and methods it has. I need to figure out how to get the body out of it. I don't immediately see anything that's going to give me back the body as a string, which is what I'd really like. Let me look at the stream.readable class. Maybe there's something here that would help. And remember, since this incoming message extends the stream readable class, it has all of the methods and properties that the readable stream class has. This could be something, readable.read, which pulls some data out of the internal buffer and returns it. Although this paragraph right here says the readable.read method should only be called on readable streams operating in paused mode. In flowing mode, readable.read is called automatically until the internal buffer is fully drained. That tells me that's probably something we don't have to manage, which is good, because that kind of sounds like a pain to have to call that to get each chunk out of the buffer. Let's see what else we have. I don't think any of that is super helpful. Is there an end? Close? When the stream has been closed? Okay. Data. Here's an end. This example might actually be pretty close to what we need to do. Readable on, listen to the data event, and then pull those chunks out. And then when we get to the end, that's when we know we have all of the data. But is that data the body? Or is it the headers, or is it everything? I'm not really sure. Let's try a search here. I'm going to try get post body as string node HTTP. Okay, here's how to process post data in Node.js. That sounds pretty good. Get HTTP request body data using Node.js. That also sounds like it could be relevant. Let's start with those. This one recommends you use Express. That is a library that makes it easier to build an HTTP server. I don't think we want to pull that in here. Here's an example of how to parse a query string, which is not what we want to do, but I do notice that part of this example is grabbing, well, appears to be grabbing a body from a post request. I say appears to be because, one, I'm inferring some things based on these variable names and no telling why or how this person decided to name these variables what they did. Also, you can't look at code examples on StackOverflow or on any other website or forum and assume that they're actually going to work. But sometimes they do, and sometimes they don't, but they give you a starting point, so it's still useful. If this does work, then it looks like the data that comes back to the callback for the data event listener is actually the body. Because what they're doing here is they're creating a body variable that's just an empty string, then they're listening for the data event, and they are taking the chunks that come back and appending them with this plus equals operator to body. Let's try that approach and see if that works. Request.onData. And we're going to get back a chunk. Let's flip back over. Yeah, that looks okay. Also, I want to look at the instructions again. This should receive only post requests. We should have a method property if this sample is correct. Let's go back and reference our documentation just to make sure that method property actually exists. Oh, we're looking at the stream readable. We're not looking at the incoming message, message headers, message method. That's what we need to look at to make sure we're only handling posts. One principle that's commonly practiced in JavaScript is to return early. I'll show you what that means and how we can practice that here. Right here inside our request listener, I'm going to start by checking if the request method equals post, and this is the only one I want to respond to. So you might think that I would grab this code and pull it up into this if statement, but in order to return early, I'm going to do this a different way. I'm actually going to check for the opposite of what I want to see. So I'm going to see if the request method does not equal post. And if it does not, I'm just going to return, which effectively ends this function. This being our request callback function. We get a request, it comes in. First thing we do is we check the method. If that's not post, then we return. That means the function returns nothing, it does nothing else. None of the rest of this code inside our callback gets executed at all. Which leaves us free to go ahead and do whatever we want to do with a post, because we know that nothing below this if statement is ever going to get executed if it's not a post. Okay, before we start listening for data, we need a variable that's going to hold our body. And I'm going to do it just like that example. Start it with an empty string, and then I'm going to append the chunk onto the string. Then we can listen for the end event. That one doesn't call the callback with any argument, so I don't need to name that parameter. And it's at this point I know I've gotten the whole body. I can now do my manipulation, change it to uppercase, and then I can return a response. I'm going to make a constant here, body uppercase equals, and this will just be the body, to uppercase. To uppercase is just a string method that converts the entire string into uppercase, which is what we want. Now I have the value to return, and now I need to reference my documentation again and see exactly how I go about returning the response. Last time I was just piping the file contents from the readable stream directly into the response. This time I don't really have that. I've just got a string. We've got response.end. That might do it since we can pass in data to it. And we have response.write, which I think we tried to use last time, and then we realized that end is maybe a little simpler. Let's just try calling the responses end, and we still have to do this inside the callback, because this callback is getting called when the request is over. The request has sent everything. If we tried to step down here and do it outside, then it would happen before the end of the request. So that's not what we want. Let's go to response.end, and we're going to return body uppercase. We've already got the code written to listen on the port passed in to the command line. Let's save this and give it a shot. I think that's everything. Clear out my buffer here with Command K, and let's run the verifier. Oh, this looks good. Looks like we passed. Let's take a look at the official solution. Okay, they've got a couple of things different here. They've brought in this through to map library, which I'm not familiar with. Hopefully, as we're going through the rest of this code, we'll be able to see sort of what it does, or at least get a general idea. They've set up their server. They are checking first thing for the post method, just like we did. The difference is they are returning response.end, which is actually a good idea. We should have returned some sort of response even if we don't get a post request. If we don't return a response, then what an HTTP client would do is it would kind of just keep waiting until it times out. So it would be better to return something that at least tells that client what's happening or why their request failed. It wasn't part of the spec though, so I don't feel too bad about leaving it out. Then what they've done is they are piping the request into a call to that map function that came from the through to map library, and they've passed it a callback function that is apparently getting a chunk and changing the chunk, and then they're piping the result of all that into the response object. So it looks like what is happening is the request is being piped in to that map call, which creates a writable stream, and that writable stream transforms the data coming in using the callback function that's passed in. So in this case, it's taking each chunk, converting it to a string, and then converting it to uppercase. Now I assume we have a writable stream that is probably also a readable stream. So it might be like a duplex stream, I think is what they call it, when you can write or read the stream. That stream is being piped out to the response. And then they're doing basically the same thing they did before to set up the listener on the server. This code's a little bit shorter than what we've written, but I really think it's a lot more difficult to read. And I can't imagine that bringing in that library made this developer's life a lot easier. And that's why you would really want to bring in a library. What we did was pretty easy and straightforward, and I can go look at this probably in 6 months and without a lot of trouble reason about what it's doing. Over here in the official solution, I'm just kind of making a lot of assumptions about what this library does. If I really want to understand what it's doing, I'm probably going to have to reference this library's documentation to understand what it does and what it returns. And then I've got to sort of unravel the various pipings first of the request into whatever's coming back from the map call, and then of that into the response. It just feels to me a lot messier. It's definitely cool, it's a cool solution, but I don't think it's as readable as ours. Let's move on to, I believe it's the final exercise. We have finally made it. This is an HTTP JSON API server. This is definitely something that you would find in the wild. There are tons of API servers that respond with JSON. We are going to create a file named HTTP JSON API Server.js. Write an HTTP server that serves JSON data when it receives a GET request to the path /API/parse_time. Expect the request to contain a query string with a key ISO and an ISO format time as the value. And here's an example of what that call might look like. The JSON response should contain only hour, minute, and second properties. Here's the example of what that looks like. Then we need a second endpoint for the path API Unix time, which accepts the same query string but returns Unix epoch time in milliseconds, which is the number of milliseconds since January 1st, 1970, 000 UTC, under the property Unix time. Here's an example of what that response looks like. And just like before, it's going to be listening on the port provided by the first argument to our program. Let's flip back over. This one I think is most similar to our time server. Where's that one? Here we go. I want to duplicate that. And what is it supposed to be called? HTTP JSON API Server. And I'm going to hide my sidebar with Command B. Bringing in the port can work exactly the same. This is actually an HTTP server, so I don't think I need net. I do need the HTTP core module, and I want to use it to create the server. Then this callback, instead of receiving the socket, is going to receive the request and the response. Let's get rid of this log. Now I'm going to refer back to the HTTP uppercaser. So we're kind of drawing from both of these scripts we wrote in the past. I didn't memorize how to do this stuff in order to put these scripts together. Since I already did it once and it worked, why not just use the code I already figured out how to write again? Looks like we are off to a good start. This is not going to be a post request, it's going to be a GET request that we're responding to. And we're only responding to GET requests. So maybe it would be nice to, as our first thing here, check if that's what we're getting. And if not, we can do what the last official solution did, and we can just send back some sort of message. Now we've handled returning early if we don't get what we expected. I know we're getting a query string with our request, and we'll need a way to parse that. I noticed in this answer we were looking at earlier that that's actually what they're doing here, is they are parsing out a query string. They are using this query string module. Let me pull that up. Since this is documented on the Node.js documentation, I know that means this is a core module, which means I'm not really hesitant at all to just use it. Since we're getting such a short query string, if I had to pull in an external library to try to parse it, I might just do it myself with some string manipulation. But since query string is one of the core Node modules, I've already got it. I don't have to install another dependency. I'll just use it. It'll make my life a little bit easier. Let's jump down to this socket write and socket on connect stuff and get rid of that. That's not really relevant to us anymore because we're not dealing with a socket. And I'm just going to come over here to the uppercaser and grab a bunch of this code because a lot of this will work for what we're trying to do. We're still building an HTTP server just like we were before. It just returns something different. Once I get this end event, I know I've got the whole query string. So this is the point at which I would parse that string. I'm just going to call it query here. After it's parsed, we're saying it's the query instead of the query string. And let's flip back over and see what they use to parse. They're using the query string module, which they have called QS. I'm calling query string, and they're using its parse method. Let me go over to the documentation and just look at the documentation for that method. Here it is, querystring.parse. It takes one required argument and then several optional arguments. The required argument is the string, which is just the query string to be parsed. Then you can set custom separators, a custom equals symbol, and you have an options object you can pass in for some other options. What we're expecting to get here is fairly standard. We're not even going to get multiple parameters, which is when you'd have to worry about this separator, this ampersand. We're not even getting that, so we don't have to worry about that at all. What we are getting, the one parameter we are getting, is going to just use equals as the equal sign. So no need to change that. I think for our purposes we can just pass in the query string. That should parse it to an object. Let's go back to the documentation. If we're looking at this example query string, here is the object that querystring.parse will return if you pass it this string. The strings before the equal sign in each segment of the query string are going to be the keys of the object. The strings after the equal sign are going to be the values. And in this case, there are two values for ABC, so they get parsed into an array. We're not going to have to worry about any of that because our query string is much simpler. One thing that's bothering me about this is the naming of body. That's not super clear. If I come back to this in 6 months, will I know what that actually is? I don't know, probably not. So instead, I'm going to change it to query string, because that is literally what it is. Actually, I'm not going to change it to query string because I already have the library, which is very close to that. That could be very confusing. Instead, I'm going to change it to request query string. And now that is the string we're parsing. Request query string. All this is in the interest of readability down the line. It also helps if I'm collaborating with other developers so that they can better understand what I'm doing or what I did. That probably won't be the case with this one. For this one, it's just for me. Now I have a query, and that query is going to have a time in it. Let's go back and look at the directions. The time is going to be on the key ISO. So I want to break it out just to make it super easy for me to get to. Query.iso. That is our time. Now that I have the time, I need to parse it into an object I can work with and spit it back out in the JSON format that we have in the directions here. 3 keys, hour, minute, and second. And then I also need to be able to spit out the object with the single Unix time key. This is where my logic is going to branch based on the URL the user has sent the request to. Let's look at the documentation for HTTP and see how we can figure that out. It looks like this message URL property might be what we need. They're not really telling me explicitly, but it appears based on this line that request.url is going to be maybe everything after the host. Let's work based on that assumption, and if it doesn't work out, we can always test that later. I'm going to call this request path. And here I want to branch based on what that is. Let's look again and see what are the 2 paths we need to support. We need to support API parse time and API Unix time. And back over in the documentation, so the only issue is it's also going to have the query string, and we don't really want that. So let's get rid of that here when we set this request path variable. Now let's figure out how we're going to actually split this up. Not every request is necessarily going to have a query string. And I'm talking in absolute terms. I think for the purposes of this exercise, every request will have a query string, but we want to write this as if maybe they wouldn't necessarily, because in the real world, they probably, you know, some would not. That means the first thing we need to do is test to see if we do have a query string, and we can test that by looking for the question mark in request.url. I know this is a string, so I can use the string includes method, and I can just look for the question mark. I'm going to use what's called a ternary. It's sort of like a shorthand version of an if statement with a single else case, where an if statement with an else case is probably going to have minimum, well, let's see, 1, 2, 3, 4, 5 lines. This can all happen on one line with just a few characters. The way you do it is you set out your condition here, which is request.url.includes the question mark. That's the condition we want to test for. Then you put a question mark, a token, not a string. That tells JavaScript that we're doing a ternary here. Then you do the positive case. So if the request.url.includes question mark returns true, what do we want to return out of this expression? And that's going to be request.url, and then we can split that string on the question mark. That gives us an array. So now we've got an array containing the part of the URL string that's to the left of the question mark and the part of the URL string that's to the right of the question mark. We only care about the left part, and that's going to be the first item in the array. So I'm going to take index 0. Then to complete the ternary, you put a colon, and now we're going to put what we want this expression to return if our condition is not true. So if the URL does not include a question mark, then we can just use the request.url. We don't have to split it because there's no question mark, there's no query string. I'll save that in my formatter. We'll split it up across lines just to make it more readable. So again, what this does, this creates a constant called request path. It sets that equal to this expression, which is a ternary. Our condition is request.url.includes a question mark. Does the request URL include a question mark? If it does, then we are setting request path to request.url.split on the question mark and give me the first item in that array. If it doesn't, we're just setting it to the entire request URL. One thing I want to see that might make this a little simpler, might do a quick refactor here. Let's just do a test. What happens if you split a string that doesn't have a question mark on the question mark? What does it give you? Oh, interesting. Even though it doesn't have the question mark, if I try to split it on a question mark, it's just going to give me an array with everything in it as the first item. The implications of that are that even if we had a query string and we split it, we still get back an array, and the part we're interested in is still the first item in the array. That being the case, we can always split on a question mark whether or not there is one in the string, and we can always take the first item in that resulting array, and that's going to be what we want. So even though I just taught you how to do this ternary, we don't actually need it, because we can just set request path to this every time. We can split the URL on the question mark. If it has it, it'll split it. If it doesn't, it'll just give back an array with the whole request URL in it as the first item. So in every case, we just want the first item of that resulting array after the split. Now that we've done all that, we have the value we want to compare. Down here, we already have our if statement, although I forgot the last curly braces. Now we have what we need, and we're just ready to fulfill our obligations for a request that goes to each of these different paths. Parse time is the first one we're going to deal with. I'm going to flip back over to my documentation, and I want to find that date FNS documentation again, because I think we'll need to use it here. Not need to, but I think it'll be a lot easier if we do. I'm just going to scroll through and see what I have, see what I can use here. Here's parse ISO. I believe we're getting that date as an ISO string. Let's look at this. Okay, I'm going to get out of my node REPL here. Let's go back up to the instructions. An ISO formatted time as a value. Yes. So parse ISO seems appropriate. Let's go ahead and do this. We don't need this format method anymore because we're not actually formatting a date. We're just spitting out various parts of it. At least I don't think we'll need that. We can always add it back in if we see that we do need it later. But we definitely need parse ISO. It takes one required value, which is a string, the value to convert, and it returns the date. File this one away for later. We're not here yet, but this is get Unix time. We're going to need that for our next method. Actually, let's just go ahead and do this while we're here. We can skip ahead. I'm going to grab this so that we can require this method. Actually, I can parse this here before we go into the if statement because I need a date from the ISO string no matter what. We'll call parse ISO and pass in our time. And I'm going to do a little refactoring here. I think time and request time, we're starting to get a little ambiguous here, starting to step on our own toes. This isn't really a time, this is an ISO time. This is more accurately the time, I think. So we'll parse the ISO time, and that's going to return a value that we're going to set as this variable time. Now we can come down here, and let's switch back to see how to use this. You just call get Unix time and you pass in a date object. So we'll pass in time. That should take care of that piece. We need to return it eventually, but that's okay. We don't have to worry about that right now. Let's go back over and see how we're going to parse out the different parts of this. What parts do we need again? We need the hour, minute, and second. So this get seconds is probably going to be useful. Now I'm thinking about how we're going to store these values before we spit them back out in the response. And I think it would be nice to do the response outside of the if statement, because that code's going to be the same. The code to send the response is going to be the same regardless of whether this request is on the parse time endpoint or the Unix time. So I'm going to make sort of a generic variable to hold the response. I can't call it response because that is the object that I use to send the response. So what should we call this? Let's call it response time. That's not great, but I think it's good enough. We'll just make it an empty object for now, and we can go back and fill it later. Actually, since it is an object, we can make it a constant because we're not going to reassign it. We're just going to add keys to it and values. Here I can say response time dot hours equals. I'm not sure what that's going to be yet. Just go ahead and set all these up. Seconds. And I think I had the method that's going to give us seconds. Get seconds, and then you pass it a date. It's pretty straightforward. Let's go ahead and bring this in. There may be a better way to bring all these methods in without having to individually require each one, but this is good enough for now. This will get us there. Here, let's call get seconds and pass in our time. I am pretty certain that these other methods are going to be named similarly, but let's just look at them to be sure. There's get minutes and get hours. And yeah, everything looks like it's exactly what we would expect based on the way get seconds looks. So I'm going to copy this get seconds require, and we're going to do get hours. Change it here too. We'll do get minutes. And now we have all of the methods we need to break these parts out. We wouldn't need date FNS to get this. The date object already has pretty easy methods to do this, but I think to me this is even easier. Oop. wrong method here, or wrong function. Okay, get hours, get minutes, get seconds. And now down here, we want to assign this to response time dot, and what is the key they want that to come back on? Unix time, all one word, all lowercase. Let's save that. Now we have our response. Now we just need to send it back. And I think we can do that in this response.end method. Maybe just send back that object. Let's switch over and look at the documentation for response.end. I'm doing a find here. Request.end, here's response.end. The data can be a string or a buffer. That is important given what we're trying to do here, because that means we can't really send back this object. Object is neither a string nor a buffer. The way we're going to get this back is we'll use the built-in JSON object and stringify the object we're trying to send back, which will convert it into a string of JSON. That should be everything we need, I think. Having said that, we've written a lot of code, so there are a lot of places where we could have small mistakes or even larger logic errors. But I do think I want to start just by running the verifier and see what it tells me. What is this file? HTTP JSON Api Server. Clear out the buffer with Command K, and let's see what this says. No, this did not work. Oh, okay. We left some old code in here, so it's trying to run this format function that we are no longer bringing in on line 15. I forgot to get rid of some of my old code. These are obsolete. They're not part of what we're doing here with this script, so we can get rid of those. I'm going to space this out just a little bit more. Make it a little easier to read, hopefully. Okay, let's try this in the verifier again. Okay, well, something happened. Submission results did not match expected. We returned the correct keys, almost. We returned hours, minutes, and seconds instead of hour, minute, second. We can fix that pretty easily, but the more difficult problem to fix is that we're not returning good values. We're returning null for everything, and I'm not clear why at this point. We can start to break that down and figure out what's going on. First, let's change those keys, take the S's off. Now that part should be good. I'm going to run it. It's still not going to pass, but we can at least see that we have the proper keys for that response. That looks good. Everything is returning null, which means that these functions that we're assigning back to keys on our response time object are returning null. I don't think there's anything wrong with those functions, so I am thinking this time is not what we think it is. To test that, we can go right here to the line where we set time. It's line 24. I'm going to drop a new line under it, and I'm going to log out time. Let's run the verifier again. Okay, and to see that output, I need to scroll up here to the top. This is what I'm outputting, I think. That's what I'm logging out. It's hard to see here, so let's drop in a label that will make it easier to see. I'm just going to name it exactly like the variable. You can pass as many arguments as you want to console.log. You just put commas between them, and it will log them out with a space between. So what we're logging out is we're just logging out time colon, and then we're logging out the value of that time variable to see what it is at that point. Let's do that. Okay, now it's easy to see. Time is invalid date, so it's a date object that is not a valid date object. Where is the date object coming from? We're just going to keep tracing this back until we find what is broken. I don't need this log anymore because I know what that is. Parse ISO, that's also coming from date FNS. I am assuming that function is okay. It's not always the case, but I think it probably is here. So I'm wondering if ISO time is not what I think it is. I'm setting that up here on line 22. Let's log it out and see what it looks like. We'll just keep tracing this back until we find the root of our problem. Oh, I logged it out without any sort of label again. This is not required. It just makes it easier to find what you're looking for in your output. Here we go, ISO time undefined. There's nothing in it. That is why when we pass it to parse ISO, it is creating a date that is an invalid date. Now let's go one step further. Where is ISO time coming from? It's coming from this query, which is supposed to have parsed the request's query string. Let's see what the query variable holds. Oh, okay. It does need to be console log. Object null prototype. I think that means this is null. That makes me wonder, if we go back one more step, querystring.parse, we're calling that on request query string. I wonder if request query string is what we think it is. I'm just going to copy that so I don't have to type it again. And I can come up here before we try to parse it and see what it is. I would expect it should be ISO equals and then whatever value they're putting in. That's what the application expects it to be. I expect it won't be that. Maybe, but we'll see. I think that may be why we're having a problem. Scroll back up to the top. Oh, I did it again. Forgot log. Okay, request query string is nothing. Now I'm starting to wonder if that example in the Stack Overflow answer that we used to try to grab the query string is not correct. Let me do a search. How to get query string node HTTP. Okay, I've got this stack question. This seems to be talking about Express though, and I think that's going to be different than what we're trying to do with just the HTTP library. So I think this may be more relevant, how to access query string parameters. Yes, this one is using the HTTP core module. They are also using this URL, which is apparently a core module in Node. Let's flip over to our documentation and look at that one. They're using the, are they using the parse? They're using a parse method. I'm not seeing that. Okay, it looks like that may be part of the legacy API. Let's just go to that and maybe they'll tell us if there's a newer method we should be using. I don't see one. Is that actually part of the legacy API? If it is, I'm not sure I want to use it. I think this is part of the legacy URL API. I don't think that's a good idea to use that. Legacy usually implies that this is old code that we would really like to get rid of, and a lot of times they do get rid of that, so then you may end up upgrading Node at some point and this code you wrote breaks because that is now deprecated, that method. Let's see what we could do instead. I wonder if we could just construct one of these URL objects and grab the query string out of it. Let's look at the constructor and see how it works. The input is a string, the absolute or relative input URL to parse. By using this, we get a parsed URL and we don't have to call that parse method that may at some point go away. Let's start by bringing this module in. Since it's a core module, I'm going to do it here under HTTP. It doesn't matter. It would still work. I could put it at the end. In fact, I have put this core module at the end. I'm just going to move it up to sort of be consistent in that convention. Now let's try this other method to parse this query string. I'm going to start by creating a variable that's URL. And it is a new object. And the object, even though here they're showing it as if it's in the global namespace, it's not for us. We're bringing it in through that URL module. So the way we would reference this constructor is we would say lowercase URL dot uppercase URL. So that would say the URL constructor, which is in the URL module. And this might be kind of confusing. This URL is in a different namespace. This only exists on this lowercase URL object. This URL is our variable that's scoped inside this request handler, this request end handler. But just to make this unambiguous, I'm going to say request URL. I think that'll make it a little more clear. And actually what I'm passing in is request.url. I no longer need this, I don't think. Actually, let's look. What tools do I have here? I have all these properties once it's parsed as a URL object that I can access. Query strings or URL parameters are sometimes called search parameters, and that is how this URL module is referring to them. So you can see .search here is the query string. We also have this .search params, which creates this URL search params object. And let's see what that is. Okay. This might work. You see how here they're accessing one URL parameter's value by addressing it through this. So they've got the URL object .search params and then .get, and then they pass in the key as a string, and it spits out the value. We can do that, and we don't actually have to parse the query string. It's already done for us. That means I don't really need this step. I can go straight here and I can say request URL dot search params, and then I'm going to do dot get and pass in the key I want to get, which is ISO. Since I'm no longer using that query string module to parse, I don't need it anymore. So I'm just going to stop requiring that. This console log doesn't make sense anymore, so I'm going to get rid of that. I do want to see if this is actually working though. Let's log out time and see if we get that far. This may just pass and it won't matter. No, it's not going to do that. Ah. Invalid URL. It could not parse this URL. Let's see if we can figure out why that is. Let's go back up to the URL constructors documentation. It takes an input and optionally a base. And here is the key. We're passing in a relative URL. We're just passing in everything after the host and the protocol. The documentation here on the input string, the description for that says if input is relative, then base is required. So this optional argument is required if we use a relative input, which we have. It seems kind of silly since the base doesn't really matter for what we're trying to do, but it is required to construct this URL, and this is saving us having to parse the query string. So let's just go put one in. In fact, I don't really think it matters what the base is because we're not doing anything with it. Let's just put in google.com because really I don't think it matters. If we were going to go and do something with that base, then it would definitely matter. If we were making a request to this URL, it would matter. But we're really just sort of leveraging this object to parse our query parameters. Let's try this out and see if it works. Oh, we're getting close. We do have our time. And in fact, we passed the first test, which we wouldn't if we didn't have the time. So I think we can take that console log out. Now, the issue is that the Unix time we're returning is not as long as the one they're looking for. Let's go to the documentation for date FNS again and look at that get Unix time to see exactly what's going on there. I don't see anything in this description, although it does say get the seconds. Maybe we need more than the seconds, and maybe that's why the other is longer. There is no sort of options we can pass in to tell it to give us more digits or anything like that, so I don't think we're going to get any help here. I do notice this get time, which gets the milliseconds timestamp of given date, and I want to see if that might be something we can test and see if this works. What I need to do is I need to go up here, and instead of this get Unix time, I'm going to use their getTime function. Let's change it down here. Let's try that. That looks like a success. Both of our results matched up to what they were looking for. So they were in fact looking for the Unix timestamp in milliseconds, and getTime does in fact return a Unix timestamp in milliseconds. Let's look at their solution and see how this works. I can tell you right away, like I said before, the built-in datetime objects already have the methods we needed to do this, and just looking at this code, we absolutely should have done it this way. We did not need date FNS at all for this particular solution, especially since if you look down here where they've declared the constant time, the built-in JavaScript date constructor will parse an ISO time string. So we didn't need it to parse the ISO time. We didn't need it to output any of these. We didn't need it to get the Unix timestamp. We should have just done all that with the built-in object. You live and you learn. Our solution works, and it's fine. They did parse the URL in pretty much the same way that we did. They dumped the URL into the URL constructor, although they did not require the URL module. So that must mean this URL constructor is just globally available in Node. If we had known that, we wouldn't have had to require that URL module. But you'll notice they've just put a fake domain too, because it's just going to get thrown out. All they care about is parsing the parameters. And here in the date constructor, they've used the search params key, and then the get method on that to get the value of the ISO key. They've also used a generic result variable. One thing they did do is they created these functions at the top that return the objects they need given the time. That's fine, not absolutely necessary. They're only doing it once, so maybe not super helpful to have a function that does it for you if you're just going to be doing it once. If you were doing these things, if you wanted to create this object in several different places throughout the code, it would make sense to have functions to do it. They're using regular expressions to test their URLs to see which URL the user is hitting. That's where we just split off the query parameters and just tested for an absolute string instead. Again, they've written headers out in their result, which is a good practice, but wasn't required. They've also stringified the result and pass it into the response.end method, just like we did. They have handling for the case where there is no result that they can return, and that's also a good practice, although it wasn't required by the exercise. They're writing a 404, which is not found. That's a HTTP error code for not found. So they write that HTTP status code to the result, and then they just send it out. If you made it this far, you deserve a cookie, and not the kind that sits quietly in your browser and tracks what you're doing as you surf the web, but the kind that's got chocolate chips or maybe oatmeal and raisins. Anyway, thanks for sticking with me through this whole series. Be sure to let me know if you liked it with a click of the like button or maybe just a comment. I'm hoping to do some more of these technical workshop series, and I hope that you'll come along with me. Thanks again for watching, and I'll talk to you in the next one.